Here are the answers for the practice problems at the end of the chapter. Pause the video, check your answers, and I'll begin to work the problems. The first question asks you to solve for present value. So question number 1, we know future value is equal to present value times 1 plus r to the t. And basically we're going to torture this equation throughout the semester, so you really have to know this. So if I'm going to rearrange this for present value, I divide both sides by 1 plus r to the t. So present value is equal to future value divided by 1 plus r to the t. And I'm going to use that equation here in the next couple questions. Okay, question number 2, put here in red, and it's important to draw the timeline. If you draw the timeline properly, you'll be able to work the problem without referring to any of the written parts. So I want this timeline drawn so that someone could walk up and look at the timeline and know the question and be able to solve it. So Derek can buy this mowing machine, and this mowing machine will pay 3 years from today a total of $10,000. And the interest rate that Derek is going to use is 10%. And he has a chance to buy today, so how much is he willing to pay today? So I put the question mark there. And now I can say present value is equal to future value divided by 1 plus r to the t. Right, in this case future value is $10,000 and 1.10 to the third. The other way I like to write that, and I prefer this, I like to say the value today is equal to the value at year 3 divided by 1 plus r to the t. And it's the same thing. $10,000 is the value in year 3 and 1.10 to the third. The reason I like this better than present value and future value is I know present value is defined correctly here as v0, and the value in the future value is defined as a value in year 3. I can read that a little bit better. It's up to you, whichever one you choose to do. And we'll go to question number 3, and we'll draw that timeline again. Question number 3 says Mr. Benson offers Derek a choice. He can either get $8,000 today, so at time 0 he could get $8,000, or at time 7, 7 years from today, he could get $15,000. And he has an interest rate of 9%. So which one should he choose? Well, I want to bring this $15,000 back to today and see how much it's worth. So the value of that $15,000 in the future today, the value today of that $15,000 at year 7 is given by this. So the value at year 7 is $15,000 divided by 1.09 to the 7th. That is equal to $8,205.51. So Derek would choose to get the $15,000 at year 7. And it's important to get this concept. The $15,000 promise, get that in 7 years, is worth $8,205 today. So he would prefer to get what to him is worth $8,205 today rather than the $8,000 today. Okay, so let's go on to question number 4. Question number 4, he's going to open a bank account, and he's going to put some money in the bank today, times 0. Let me get that written correctly. Times 0, and we want to know how much he's going to put in there. And we know he needs to have, by year 12, he needs to have $37,000. So what can he do? So I can say the amount he has to have today, the value in the account today, or the present value, is equal to the value at year 12, we call that the future value, divided by, and the interest rate the bank is going to pay is 11%, so divided by 1.11 to the 12th, that's $37,000, divided by 1.11 to the 12th, and that's equal to $10,576.11. So what's happening is he puts this money in the bank today, and it grows at, in this case, 11% for 12 years and becomes $37,000. Now question number 5 says, well, what happens if the interest rates go down? So it didn't say how far. Let's just say, what if this were lower? Let's pick something like 1.08. So if it was a 8% interest rate instead of 11% interest rate, then the denominator here is going to be a smaller number, which means this is going to be larger. So if rates go down, lower rates, it means he has to make a larger deposit, right? Because you can think of it this way, he's earning less money, so the bank is doing less work for him. He has to put in a bigger amount. And the converse is true. If this were higher, if this were like 1.13, this would be a bigger number in the denominator, and this would be smaller. So higher rates means he would make a smaller deposit. It's very important to remember that. As rates go up, present values go down. If rates go down, present values go up. Okay, now let's go on to number 6. In number 6, we're looking at future values, but still important to draw the timeline, and we want to see exactly what's going on here. Suppose you deposit $2,000 today, so $2,000 is deposited today into the account, and the account earns 10%. In 3 years, how much will you have in that account? Well, the value at year 3 is equal to the value at year 0 times 1.10 to the third, which is $2,000, times 1.10 to the third, which is equal to $2,662 exactly. Okay, I want to do number 7 right here next to it. Number 7 is going to be very similar. So he's going to deposit $4,000 today, and in year 3 wants to know how much is in there, and the account's still 10%. Here's what I want you to notice, and why I wrote the problem this way. If 2,000 becomes 2,600, 4,000, which is double 2,000, will become twice this. You can check it out this way. I'll do the same setup. V3 is equal to the $4,000 today times 1.10 to the third, which is equal to $5,324 exactly, which is exactly twice that amount. Okay, next one I want to do number 8 right here with it. We'll put them all together, and number 8 is going to be very similar. And it says we're going to deposit $5,000 today into an account, and it's going to earn 10%, so the interest rate is still 10%, and we're going to see how much is it worth in 5 years. So that's the question. What's it going to be worth at year 5? So the value at year 5 is equal to the value today at year 0 times 1.10 to the fifth. The value today is $5,000 times 1.10 to the fifth is equal to $8,052.55. Okay, so number 9 says, what if the interest rates are different? Repeat 6 through 8. This is just to make you do this again and again and again and see if your answers make sense. So what if I come through here and say, alright, the interest rates are not 10%, they are 12%. Let's see if I can get a different color here. I'm going to do this kind of green color for the 12%. So if this was 12%, then this has to be higher, right? Because having 1.12 to the third will make this a bigger number, and it sure does. It comes out to be $2,809.86. Now it's important every time you work problems to make sure they make sense, the best that you can. So this 12%, I know making this 12% right here is going to make this a bigger number, and it does, 5,619.71. Likewise, making this 12%, changing that to 12, will make this number bigger, which will be $8,811.71. Well, then let's go through and make the interest rates lower. Well, if that's the case, let me see what I can do to come up with a better color here. I think I can really get much of a different color. We'll just go with that one. Let's go with this. Instead of 12%, Well, if this is 8%, well, if this is 8%, you know it's going to be lower, right? So that's going to be $2,519.42. So again, we're repeating the same thing, but if I put in an 8% interest rate, it's going to be lower than both of these, and sure enough, that's $5,038.85. Same thing here, putting in 8%. So this, of course, is 8%, and that's going to be a smaller number, which would be $7,346.64. Okay, so hopefully you have that good repetition. Of course, this is answer number 9. Now that you've done that repetition, hopefully you're strong with this foundation. You need to be strong with this foundation because that's what we do for the rest of finance, is time value of money.